Should I close that? Good afternoon, everyone. So we'll start our first session on Galfit. So have any of you tried running it? Or yeah, so okay, so I'll assume as of now that this is just the first. I don't understand. The volume is zero. Yeah. Can some of you speak out and let me know whether I'm audible to you?
Yes, sir, you're audible.
Okay. Yeah, so we have had talks on galaxies, and we have seen that galaxies come in all kinds of shapes and so on, right? And very often the shape of the galaxy also depends on it depends on how are we observing it, in which waveband are we observing it, and that makes all the difference. So one aspect is observation. If you look at a galaxy in optical, you will see light from stars. The visible light is what we see. But if you observe in infrared, then you will see distribution of gas and dust and colder regions. You go further into longer wavelengths in radio, you can see distribution of uh, hydrogen gas and etc. And if you go towards the high energy side, go into try to observe in X-ray or so, you see very energetic objects which are emitting in X-rays and so on. So one thing is the morphology of a galaxy could appear different if you are observing it in different wavebands. Okay, but even if you observe in say visible light, uh, sometimes when you look at it, the galaxy appears to be, say, an elliptical galaxy. You see a uniform distribution of light and it spread over an elliptical. We'll see some examples of that. But when you do a little bit of image processing, or if you use certain techniques, we can find out whether there are some features within it. Yeah. So Galfit is one such technique. Galfit is a program where you can fit models of galaxies to your image, right? So suppose I look at the image and it looks like an elliptical one, and I see that its minor axis is of certain size, the major axis is something else, and it is tilted by a certain angle. I I construct a mathematical model of a similar galaxy with the same kind of parameters, same minor axis and major axis, and twist it by the same angle, and make it of the same size as you are getting it on your um, on your in your pixels. And there are various mathematical models which show how light distributes in different types of galaxies. For example, if it's an elliptical galaxy, how does the light intensity fall? At the center, always you will see greater intensity coming, and as it goes down, it falls by a certain law, some power law, right? If it is a disk galaxy, then light falls by some mathematical function. So there are various mathematical models which we shall see later. But as of now, what we are going to do is we'll look at how Galfit essentially works, so that you first try it out, download it, install it. There is no installation in that, and then start using it. As far as I know, this Galfit, you can run it on Linux systems, Unix or Linux systems, or Mac. I don't think you can run it on Windows. So you have to partition your hard disk, put Linux on one side, and there are various astronomical tools, programs which run only in Unix kind of a platform, Linux, Unix, or in Mac. You may not find equivalents in Windows. Many open source have both versions, like we have seen, but some you have to resort to this. Okay, so I think I have shown you, but let's again have a look and see how we can get this Galfit and what do we have to do. And I will share the screen. And okay, yeah, so you go to your favorite search engine and say Galfit and say put astronomy to make it little more. Yeah, and there it is. See, can you all see the web page? Galfit homepage, Carnegie Institute for Sciences. So if we click on this, we get the Galfit, page, and right on top you can see what I was talking about. You have an image in the left panel. Yeah, one, two, three, four, five objects, and the leftmost panel is the image. The middle one is a model, and then when you subtract one from the other, if the model is perfect, then the residue which you see on the right side would be a blank one. It will be absolutely uh, clean, right? Because you are saying a galaxy looks like an elliptical galaxy where the intensity falls by a certain thing, and you are making a model, mathematical model, and you subtract one from the other. And if it leaves nothing at all, implies your model is perfect. But so there are times when you get a totally clean residual image, and that would imply the model which you have fit is perfect. But many a times you do get some features, certain things which are sitting behind, and you see finer features. So yeah, so we will see some examples of those. And see again here, there's an animation of Galfit, which is subtracting component wise, it's removing, and it is showing that all these features are there, right? In this, yeah, the image is this, from which you subtract the model image, and you get all these kind of dusk lanes or features and other things. Okay, so when you do that, you'll see. So what do? You come and download whichever version of Linux you are using, or whether you are using Mac OS X, Mavericks, or pre-Maverick, whichever you are using, Red Hat 64-bit, or Debian Ubuntu 32 or 64, whichever you have. And we click that, and you download, and you see below here, it is downloading a tarball, right? It is, if you can see the file name, it is galfit3 debian 64.tar.gz. So you unzip it and you untar it. Yeah, so what will happen when we do that? I will shift my camera to my Linux system, and when yeah, just a minute, I will. Okay, so yeah, before we move out from this page, there are certain other things which you should see. There is an original paper on Galfit, Peng et al. This one you should download, 2002, and the paper on new Galfit version 3. So these two you better download and have a look. It explains how to use Galfit. And Galfit, it's an art by itself. The more you get into it, the better you will become at the whole thing. So then there are some instructions to using Galfit, and then there are certain sample files here. Bare bones version 3 plus. So if you click these, you will see that you get a file, an ASCII file. Yeah. So you save this file, save it wherever you wish you want to. Yeah. So this is example.txt. And similarly, we would have saved the other files. Okay, so what are these files? We will just come to it in a moment. And similarly, you have this all possible function types, constraint files, and so on and so forth. Yeah, constraint. Similarly, you download the constraint files. So these constraint files and all, how do we use it? We will see it a bit later, but there's no harm in keeping it in some directory where you are going to work in. Okay, so now I will switch to the Linux system, and just a minute. Yeah, where is it? Stop share. Yeah, so now I will try to log in from the Linux system, and okay, yeah, okay. Host, can you enable me share?
Actually, I have enabled everybody to share. Okay.
Hmm?
I think you can share now. I think you can share. You are co-host. Your SNS no why?
The whole thing is hanging, I think.
You pressed it. Why are you recording on that?
I'm recording. Okay, maybe I will use the other technique. I hope, because yeah. So what I will do is somehow this is a very primitive computer, but yeah. So what I have done is I have downloaded. Uh, can you see this?
Sir, can you share screen from this laptop?
That's the problem. Yeah, that's what I was trying to do. And let me. Yeah, it's essential that I can share it from there.
This will not do, Najan.
This will not do.
You can't see me. It won't do.
This will, Priya.
No, you can't read only.
Okay, I will try to share it again.
Browser से देखो. Browser से.
I will
So we
try.
can see the laptop, but we can't read anything from the screen.
Yeah. Here is Galpit running on your system.
It used to. Now it doesn't.
Yeah, so actually it's a tar wall. When you open it, it just creates, it gives you a executable file.
Let's
And
see if I can do this.
let me see, just a minute. Just pause the recording.
You can even stop the YouTube live.